So here we have the Pythagorean Theorem, and this is a really important concept in geometry, as we will later see, as well as in trigonometry. We know that the cosine square theta plus sine square theta is equal to 1, the distance formula. These different identities and formulas that we see are really all derived from the Pythagorean theorem. So this theorem states that a squared plus b squared is equal to c squared, where a and b are the legs of a right-angled triangle and c is the hypotenuse. So the image here, I guess, would be, again, this must be a right angle again, which means that it's 90 degrees. This is A, this is B, which are the two shorter sides of the triangle, and C, being the hypotenuse, is the longest side of the right-angled triangle. And so this must satisfy here, so for the Pythagorean theorem. And really any values that satisfy this theorem are known as Pythagorean triples. For instance, 3, 4, 5 is a Pythagorean triple. Why? Because 3 squared is 9, plus 4 squared, which is 16, gives us 25, and 5 squared is 25. Therefore, this is a Pythagorean triple. Now, looking at 8, 15, 17. So 8 squared is 64, 15 squared is 225. Adding these two values, we get 289, and 289 is the square of 17. Therefore, this satisfies the Pythagorean theorem, and thus 8, 15, 17 is a Pythagorean triple. And of course, there are many more Pythagorean triples that exist. So now, if you are given a question or something like this, where it's not as easy to identify, you will be using the formula, obviously. For instance, if you're given something like, something like 7, 15x, and you know that this is a right angle here. So 15 is the hypotenuse. Now you would obviously square 15, that gives us 225. And then you know that 7 squared is 49, so you're subtracting 49 from 225. And so if we do this, we should get basically 176, right? And what this again essentially means is that 176 is the value of x squared. So this is equal to x squared, because we really did c squared minus b squared is equal to a squared. The value we get is a squared, or in this case x squared. Therefore x is the square root of 176, and is thus our answer. You want to verify this? You really do the square of the square root of 176. Again, a square root and a squaring that undo each other. So that would mean squaring this is 176 plus 49 would give us 225, which is really the square of 15. Therefore, this satisfies the Pythagorean theorem. So these are, again, some just basic problems that you should keep in mind, and you're just substituting the values into this formula. Now, there's something else. Obviously, there's a proof that goes along. In fact, there are nearly over 300 proofs with the Pythagorean theorem, and that's a lot for sure. So here I have one specific proof that I want to go over, just because I think it's good and it's easy to understand. So we have a larger square here, and we have another square that's you could say inscribed, or a square within the larger square. And really, we have an alternating sequence. You have AB, 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 and AB. And all of these sides are C, 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 C. Now, the area of the smaller square is obviously C squared, because it's C times C. The area of the larger square is A plus B squared, right? Because A plus B times A plus B, that's A plus B squared. Now, if we subtract the area of the smaller square from the larger square, that really means we're doing a plus b squared minus c squared. And what should that give us? Well, it should give us the area of the 4 smaller triangles. Now, how do you find the area of a triangle? It's half times base times height. So you have half times a times b, half ab. However, there are 4 triangles, which means half times a times b times 4 is 2ab. So this must be true by just looking at the diagram. Now, we do this again. This is another formula that you should know. It's just a squared plus b squared plus 2ab, and then we have the minus c squared. Minus c squared should give us 2ab. And looking at this, 2ab cancel, and we have a squared plus b squared minus c squared is equal to 0. Moving the c squared here, we're left with a squared plus b squared is equal to c squared, which is the Pythagorean theorem. So in this one, we have proved the Pythagorean theorem. Thanks for watching.